Hey there, guys. This video, I'm going to talk about function notation with word problems. And this is probably one of the most exciting sections in Khan Academy I can think of. And the reason it's exciting is because it is difficult. It's challenging. It makes your brain think about not just math, but what it really makes you think about is the real world context and how it relates to these symbols that we call function notation. This is a hard section, okay? This is not easy. However, the one thing that's nice is your answer is in front of your face. It's either A, B, or C. You don't have to create the answer from your own brain and type it in or nothing like that. So there is a little bit of luxury in that you get to look at what the three options are and kind of, figure out which one it may be. As I go through the problems, I'm going to try and answer it from as if I didn't know the answer, and then we'll find the answer, okay? But you guys could obviously do process of elimination to figure out what it is. So a couple things we need to first talk about is just in the beginning here. You're traditionally used to saying, well, X is my input values and Y is my output values, right? And that's fine, that's true, that's a function, nothing wrong with that. But when we're dealing with function notation, a couple things. One, it's no longer Y as the output. It would be something different. And the second part to it is that usually now we're starting to use different letters because those letters stand for things and we want a little bit more meaning to our letters. We don't want everything to be X and Y. We'd like to have a little more, variety and diversity in the letters that we use. So let me clear those off. Our input is always going to be inside parentheses. And for all these problems, ignore what's beneath this point to begin with. In the beginning, you need to read what's up top. For all these problems in this section of Khan Academy, you got to really understand the context before you start looking at the specific problem. Corey, that's what I'm going to call this guy. Corey's making a free throw or taking a free throw. Don't know if he made it or not. Is taking a free throw. H of D models the basketball's height in meters at a horizontal distance of D meters from Corey. So whatever's in parentheses is your input, all right? So your input is in parentheses. So in this case, we have H of the input value, all right? I'm gonna write it like that because I think it's helpful if I actually look at it that way. H of my input value. And the output is this entire thing I just drew up here. That entire thing as a whole is the output. So if you're wondering like, well, what is the output? It's not Y, it's not H by itself. It's actually that entire thing. It's H of whatever number you chose. And that takes some time to get used to, but that's function notation, and that's just a little bit of work here. So when we have H of R, what we're saying is R is the input value, okay? We're inputting R into this function. Let me go back up here and relate to it over here. If D is the input, D stands for, and I'll do it this way. What I'll do is I'll kind of highlight it with, we'll do blue for this. D is the meters, the horizontal distance of D meters from Corey. So he's shooting the ball and it's landing somewhere. I think a picture may be helpful here. He shoots the ball, all right, in the air somewhere. All right, and Corey's right here, right? Like he just shot the ball. Whee, there's Corey. Okay, a horizontal distance of D meters. So we're not talking about how far the ball is from him. We're not talking about how high the ball is. We're saying from where Corey's at, horizontally to the left, this distance is what we're talking about. So D is the distance. That's supposed to be a D. Let me draw that again. D is the distance from Corey's body to wherever that ball is at, horizontally measuring it, all right? H of D, the output, is H of D. H of D models the basketball's height in meters. So H of D is the basketball's height. So we're not talking about how far away it is from Corey. We're saying the basketball to the ground. This distance is the height, which is H of D, right? H of D is the height. So our input is D, which is the horizontal distance. That's the input. And the output is the height, H of D. What we're saying here is this reads, let me read this to you guys a little bit. And this is not easy for me to explain, but I'm doing the best I can, I promise. This right here reads, the output of having an input of R equals 4. So let's think about that kind of a little bit different. When the input is R, the output is 4. That sounds a lot better. When the input is R, the output is 4. I know this because R is the input. So when R is the input, this entire thing is my output. The output, equal sign, is 4. When I have an input of R, meaning when the horizontal distance is R meters, the output is 4. When the horizontal distance is 4 meters, so this is 4, this is 4. When the horizontal distance is 4 meters, when the horizontal distance is R meters, R is just some unknown variable, some letter, the output is 4, the height is 4. So he's R meters away from the ball, horizontally speaking, and the vertical height of the basketball up in the air is 4 meters in the air. So we got to figure out which of these it is. What we're saying, though, is that the ball is R meters away from him, and it's 4 meters up in the air. The ball was at the same height at the horizontal distances of 4 meters and R meters. That's not true. What that would look like is H of 4 equals H of R. That's what A is talking about, so that's not right. At a horizontal distance of R meters from Corey, the ball was equal to 4, the ball's height was equal to 4 meters. I believe that's our right answer. At a horizontal distance of 4 meters from Corey, the ball's height was equal to R meters. What C's talking about, it's wrong, but they're talking about though is they're saying H of 4 equals R. They have the R and the 4 mixed up over here, kind of backwards. So the correct answer on this is actually going to be B. At a horizontal distance of R from Corey, the ball's height was equal to 4. Now, in order for me to solve this, I had to do a couple things. I had to do a little bit of highlighting and a little bit of marking and annotating and doing some things. But what really helped me out in this problem was making the picture. I'll be honest. Without the picture, this would have been a lot harder of a problem. So anytime you're trying to take something that's in context and you're trying to convert it into math language and solve problems, if drawing a picture is beneficial, by all means, draw a picture. It is definitely helpful. 1 for 1. Good start, guys. Let's go ahead and clear that off. I'm going to do 3 more problems. I probably won't spend as long on it, but I may need to. Here we go. I'll start with blue. Jace is a taxi driver. M of N models Jace's fee in dollars for his nth drive on a certain day. So what I'm going to do is go blue. I'll do M of, and then what I'm going to do is go pink for my input, N. That may help with some of this if I just color coordinate a little better. M of N. N is the input, right? N is the input. And what is N in this case? N is his nth drive of the day. And the output is that entire thing. So the output is M of N models Jace's fee in dollars. So we have an input and we have an output, right? We have, I'll just do that in text. This is the output. Let me see if I can make that not so in the way. Output. And we have a input. We have something that's going into a function and we have something that's coming out of a function. We're plugging in the nth drive on a certain day, and what we get out of that is how much money did Jace have to charge the customer. So let me just make sure you understand the concept here. Taxi cab driver, right? So Jace goes around, he's driving, he stops the car, he says, hey, get in. Well, that's not how it works. That's just how it works in like the video games. So the person calls for a taxi, right? So he's driving around and the person's like, hey, are you my taxi cab driver? And he's like, yep, that's me, I'm Jace. All right, guy hops in. That's his first drive. He goes, he drops him off somewhere. Then he goes and picks up his next customer, and then they're on their second drive. So every drive he does is our input value. So if you're talking about an input of 3, you're talking about on the 3rd drive. Input of 10, on the 10th drive. Input of 11, on the 11th drive. The output is how much did the customer have to pay? So what does the statement M of 10 equal K mean? What that means is the output, oops, I don't want to do that. Let me undo that. Oh, okay. Let me get away from that. That works. The output value of having an input of 10 is K. Let me read that a little different. When the input value is 10, the output, this entire thing is the output is K. When the input value is 10, the output is K. Let's start converting that into this specific problem here. When the 10th, on the 10th drive of a day, on Jace's 10th drive, the output is K. On Jace's 10th drive of the day, the output is K. So that means that on the 10th drive of the day, Jace had to charge the customer a fee of K dollars. Jace's fee for his Kth drive is equal to 10. That's wrong. What they're saying there is, this is wrong. What they're trying to say there, that would be M of K equals 10. Saying that on his input value, K, on his Kth drive, it's $10. That's wrong, because we're looking for the 10th drive. Jace's fees for his Kth drive and his 10th drive are equal. That's also wrong. What they're saying there is M of K is equivalent to M of 10. That's something different than what was up there in our problem. So M of 10 equals K. We're saying on his 10th drive, the fee is equal to K dollars. Yeah, Jace's fee for his 10th drive is equal to K dollars. All right, let's keep it moving. 2 for 2. All right, let's take a look at this one. Princess Tower in Dubai is considered the world's tallest residential building, towering to 101 floors. So all those buildings, that you see in like New York and stuff, some of those tall ones, they're not residential, right? Like they're offices and stuff. So in Dubai, they actually have a tower of 101 floors. That's pretty tall. It's people live in it. All right, that's crazy. T of N models the number of tenants living on floor N on the tower. Let me go ahead and set this thing up. We're talking about T of, and then in parentheses here we have the N. T of N. That's our entire function, right? That's our output as a whole. I'm going to highlight some things here in pink. N is the the models the number of tenants living on floor N of the tower. So the N is the floor. So it's 101 stories tall. So there's if N is 88, we're talking about the 88th floor. If N is 50, we're talking about the 50th floor. And then we have for blue, T of N models the number of tenants living on that floor. So if N is 50, we're talking about the 50th floor, the output would be however many people live on the 50th floor. So if we're talking about the 50th floor, maybe there's 1,000, no, 1,000, that's a lot of people. Maybe there's 100 people that live on that floor. I don't know. So the output is the number of people that live on the floor. The input is what floor you're talking about. All right, think of it that way. Here we go. What does the statement T of 60 is greater than T of 10 plus T of 30 mean? A lot of stuff over here. I'm just going to say ignore that for a second. Let's just narrow down T of 60. The output for an input of 60, okay? So I'm going to read that the other way. When the input is 60, we have an output, right? And the input is floor N, which is 60th floor. So we're saying the output for the 60th floor, like when you go to the 60th floor, you'll find an output, right? When you go to the 60th floor, there are how many people? There are a certain number of people. We don't know the number, but this is the output of the 60th floor. This side of the inequality, forget about the right side. This side of the inequality is saying number of people. This is supposed to be a number of people sign. And let me actually draw this. This is saying number of people on 60th floor. And I'm actually going to put that probably somewhere else because we're not going to be able to see all this if I put it right there. Number of people on the 60th floor All right, that's what this thing right here is saying. Number of people on the 60th floor is equal to T of 10. Kind of the same thing, different floor. It is equal to number of people on 10th floor plus, and then you got this T of 30. Same thing all over again, just now a different floor, right? Now you're talking about the 30th floor plus number of people on 30th floor. So let's take a look at what this equation really means. We're saying the number of people on the 60th floor is not equals. I don't know why I drew equals. Shame on me. That was a mistake. It's all right. Is greater than the number of people on the 60th floor is greater than the number of people on the 10th floor plus the 30th floor. So when you combine the 30th floor and the 10th floor together, there's still less people living on those floors than there is in the 60th. So let's go ahead and go through these. The number of floors with 60 tenants, is greater than the number of floors with either 10 or 30 tenants. That's something different. Let me think about how I would write that though, because that obviously has to be represented somehow symbolically, right? The number of floors with 60 tenants, right there, what they're saying is that's harder to symbolize. I'm not going to confuse you guys. All right, the height of floor 60 is greater than the sum of the heights of floors 10 and 30. I think that's correct, but let's just check here. There are more tenants on floor 60 than there are tenants on floors 10 and 30 combined. Actually, I think that one's correct. Let me go back up and read this. The height of floor 60, we're not even talking about height. So that one's wrong, right? I almost fell for it. I almost went for the wrong answer. The height of floor 60 is greater than the sum. It sounds nice, but we're not talking about height at all. We're talking about the floor number and how many people live there. Right here, it's going to be C then. There are more tenants on floor 60, so floor 60 here is going to have a bigger number than there are on floors 10 and 30 combined than this side of the inequality. I almost got duped. Duped? Is that the right? Duped. Duped. I don't even know what duped is. I think that's something to do with going to the restroom or something. All right, here, let's go ahead and clear this out. We got one more to go. 3 for 3. I'm feeling good. Alec went for a walk. We got ourselves D of T. D of, and my input's going to be T. I like this color coding kind of concept. It seems to work for me. If it doesn't work for you, oh well. But it seems to work for me to have some color codedness to this. D of T models the distance Alec walked in kilometers after T hours. Oops, I want to go to the highlighter here. T hours. So our input is T hours. That's our input. We always know our input is in parentheses, right? And then our output is D of T. D of T models the distance Alec walked in kilometers. Okay, there's our output. So I have an idea of what my input is and what my output is. Let's go ahead and start reading this thing. Talking about going for a walk real fast before I read this thing. We're talking about, there you go. After so many hours, how far has he walked? So that's pretty easy to think about. This is a confusing looking one, but I'm going to walk us through it the best we can. Forget about this side for a second. Just focus on one thing at a time. D of 0.5. With an input of 0.5, you get an output, meaning after 0.5, after 1/2 hours, Alec has walked some distance. We don't know what the distance is, but this is the distance Alec walked in half an hour, all right? Distance, I'm gonna put that kind of like we did last time here. I'm gonna type this in here. Distance Alec walked in half an hour. All right. Distance Alec walked in half an hour is less than, I'll go back to text now, is less than the distance Alec walked in 1 hour. I'm doing that next piece, right? This thing right here. The distance that he walked in 1 hour minus, there's that minus sign right there, right? Minus, and then there's one more thing there. It says d of 0.5. That's the same thing all over again. Distance Alec walked in half an hour. All right. So however far he walks in a half an hour is some number, right? Like this is how far he walked in a half an hour. This is how far he walked in a full hour. This is how far he walked in half an hour. We've got a subtraction thing going on here. So that's kind of confusing a little bit. But what I think we would want to do here is probably think about, what does that mean? What do you guys think? And I think I need a picture for this one to help us out here. So he is going for a walk, and we don't know if his walk is uphill, downhill, what it is. But he goes for a walk, and I'm not going to make it a straight line. I'm going to say it's like a windy path, right? He's on a hike is the way I'm envisioning it. He goes on a walk, and this is where he starts, all right? So when he's here, you have t equals 0, all right, the beginning of time. And when it ends, or wherever we're at, let's just say he's over here, this is t equals 1. So what we're saying is, however far he walked in the first half an hour is less than the entire thing minus the 0.5. So let me just first try to understand. First off, halfway does not mean half the distance. It means half the time, because our input value is hours. So it took him half an hour to walk some distance. So let's just say right here is where he's at after half an hour. We don't know if it's halfway in distance. We don't know that because we don't really know our outputs just yet. So he starts walking. Here's where he's at after half an hour. Here's where he's at after a full hour. We're saying the distance that he walked in the first half hour. So let me make that like a color. Let's go with green. This is the distance he walked in the first half hour. All right. The distance he walked in the first half hour is less than the distance he walked in the full hour minus the first half hour. Are you with me on this one? That was a weird one. This thing's weird right here. That thing's weird. All right, let's talk about it. This is telling you find the full length, the full distance. The full distance is this entire thing, right? And take away the green part. And when you do that, you end up with, let me see if there's a way to pause this thing. I have an intruder in my classroom. An intruder. There's probably a way to pause. How do I pause my video? Pause share? Okay, I'm almost done. So we have the full hour, right? This is the full hour. And then when we take away the first half hour, what you're left with is the second half hour. So what they're really saying is that the distance walked in the first half hour is less than the distance walked in the second half hour. So however far Alec walked in the first half hour was not as far as the second half hour. But let's see which option. It's multiple choice. That'll help us out. She doesn't care. All right, the distance Alec has walked after walking for an hour is greater than the distance he has walked after half an hour. The time it took Alec to walk the first half kilometer is shorter than the time it took him to walk the following half kilometer. Ooh, that's tricky. The distance Alec walked during the first half hour is shorter than the distance he walked during the following half hour. It is going to be C, and the reason it is C is because we're mostly talking about the first half hour versus the second half hour. So the option B is talking about half kilometers and stuff, so that's just wrong. It is going to be C. All right. Let me know if you need help.